All right, so let's go ahead and solve this system. Once again, my goal is to try to eliminate the same variable in a couple of different ways. And I noticed that all of my z's are either 1 or -1. So that's really nice. So I'm going to start out by pairing up equation 1 and equation 2. All right, so I have 2x minus 3y minus z equals 0 and -x plus 2y plus z equals 5. And then I can very quickly add those equations together because the z's are going to be 0 when I do so. So I'll have x minus y equals 5. So let's call that equation 4. And then I'm going to do the same thing, but this time I'm going to pair up equation 1 and equation, equation 2 and equation 3. Because they have a positive z and a negative z. So that is -x plus 2y plus z equals 5. And then 3x minus 4y minus z equals 1. And then again, because I have a positive z and a negative z, I know those are going to be 0 when I add them. So I'm going to add the rest of the equation together. And that will be equation 5. Now I can take those two equations and pair them up. So I'm going to have equation 4 and equation 5. So x minus y equals 5 and 2x minus 2y equals 6. So something interesting is happening here, and you might already kind of be suspecting something weird is going to happen, and you would be right. Let's eliminate x. So to do so, I'm going to multiply this equation by -2. So if we rewrite our two equations, equations 4 and 5, after we multiply equation 4 by -2, we get -2x plus 2y equals -10, and then leave equation 5 alone. So now we have, again, the same coefficient, one positive, one negative, in front of x. So when I add these together, I get 0x, but I also get 0y. So this whole left side of the equation becomes 0 equals -4. And this is a red flag, right? Because 0 can never be -4. I know at this point in my process that I can stop and I can say that there are no solutions to this system.